Let's move on now to letter E. In letter E, I have a fraction on one side and a fraction on the other side. So this is actually going to be not too bad to start off. Let's see how this one works out. So I'm going to have, I'm just going to cross multiply right away. X plus 5 times 2x plus 8 equals x plus 4 times x minus 2. Now, the only way for me to move forward on a problem like this is to actually FOIL these out. Um, Unless there's something that can be canceled on both sides. Hold on, hold on, hold on. Look at this. I'm going to factor a 2 out of 2x plus 8. That's going to give me 2 times x plus 4. And look, now I have x plus 4 on this side and this side. I'm going to divide both sides by x plus 4. That's going to cancel out the x plus 4 and make my life so much easier. I'm just going to put this times 2 out front instead of in the back. So now I'm going to distribute. This becomes, instead of 2x plus 5, that becomes 2x plus 10 equals x minus 2. Okay, I'm going to subtract x from both sides. That gives me x plus 10 equals negative 2. And now I'm going to subtract 10 from both sides. I get x equals negative 12. Okay, x equals negative 12. Let's just see if I answered that correctly. Now let's just double check and make sure. If I plug in negative 12 for these denominators, I'm not going to get 0, am I? 2 times negative 12 is negative 24 plus 8. No, that's not 0. Negative 12 plus 4. Nope, that's not 0. Okay, it's fine.
Finally, on to letter F. It takes John 2 hours to mow the yard. Sarah can do it in 3 hours. How long does it take them to mow the yard together? Now, to solve this problem, the setup is really important. You're going to run into problems like this, so pay really close attention because they're all set up the same way. Now, here's the thing that we need to pay attention to. It doesn't matter how many hours it takes John to mow a whole yard. He's not going to mow a whole yard, or Sarah's not going to mow a whole yard either. What they're going to do is each of them are going to contribute to mowing 1 yard. So I don't care how many hours it takes John to mow the yard. What I care about is how many yards does John mow in an hour. In 1 hour, John mows 1/2 of a yard, or 1/2 times y, plus Sarah mows 1/3 times y in a single hour. And now the question is, if they both do that, how long is it going to take them to complete one complete job? This is the way this is set up. Now, if I were to write this out in a more friendly fashion for the way that we're doing things, I probably want to put y over 2 and then y over 3 here instead of using the 1/3. Okay. And then let's put here. Okay. And then the question is, how long will it take them to mow the lawn together? Y is the time it's going to take them to mow 1 yard. Okay. So let's see how long it takes them to mow 1 yard if John does half of a yard per hour and Sarah does 1/3 of a yard per hour. And all we're going to do is solve this. Now, I can't combine these two fractions until I get a common denominator. So I'm going to have to multiply this one by 2 over 2. That's going to become 2y over 6, right? 2y over 6 is the same as y over 3. This first one's going to become 3y over 6. And I get a total of 5y over 6 on the left. So it's going to be 5y over 6 equals 1. Then I'm going to, and it's just 1 over 1, right? So I'm going to cross multiply. And that's going to be really simple because it's just going to be 5y equals 6. 5y equals 6. Or how long does it take to mow 1 yard? It takes 6/5 of an hour. That's 1 1/5 hour, or 1.2 hours. Is the same as 1 1/5. Let's see if we did that right. 1.2 hours. 1 1/5 hours, same thing. Okay, so that's how you solve that type of problem. You have to set it up as a fractional problem. And even if you didn't understand why I set it up the way I did, the setup is always the same for these types of problems. You turn each of these numbers of hours into a fraction multiplied by the variable, and it equals one complete job. All right, and that is how you do these sorts of problems. You're ready to work the problem set for next time.